Alright, so what do I do here? No way. Take ln of both sides, so I get, let me just rewrite it here real quick. Take ln of both sides, then I can, now why exactly can I bring that down? Because I have an ln here, don't just start bringing stuff down just because you know you need to. I mean, the reason I'm allowed to do this is because it's a property of log. So you have to have a log there before you do that. So now I put a log there, now I can take an x down. So you get the exact answer, I just divide. Beautiful. So there's the exact answer. Got it. And then you get the approximate answer. Just to show you this, natural log 19. Close that dumb parenthesis we didn't need in the first place, thank you. Divided by natural log of 2. That one don't matter, but you can close it if you want to. So you get 4.248 approximately. Yeah.
How come you did it that way instead of switching the 19 into the power and solving that way?
How? So here's the original problem. How do you switch the 19 into a power?
Well, like, you know, when you, like, log base 2 of 19 equals...
Oh, sure. Log base 2 of 19 equals x, sure.
Yeah.
And then if you use change of base, it'll be natural log of 19 divided by natural log of 2, which is...
Oh, okay.
Yeah.
I forgot to do change of base.
Are those just two different methods?
They're two different forms of the same thing.
Oh, why did you use log base 19 over log base 2? For, like, the change of base? How'd you know to use the change of base formula?
All right. So I know that the latest iteration of these calculators have log base anything. The idea of change of base formula is used in a few other places in mathematics, so it's important to know it by itself, right? And the idea of using logs to solve equations goes beyond this, so it's important to know that by itself also. I like it. So there's always, believe it or not, a method to my madness. Yes?
So when I did log base 2 to the 19th, I got, like...
But there's no 2 to the 19 here.
It's not?
No, definitely not. There's no power in here. Nothing is to a power. See how log and 19 are on the same line? That's base 2. So you have to know log base. You have to know where that is in your calculator. And in case you didn't hear Will earlier, don't say it again. It's too bad. Nah. So there you go. There's a really good reason why we do this, so we're able to do it without knowing that extra little stuff in the menu, blah, blah, blah. Like this can use log buttons that are on the face of your calculator.
The other log button's like a cheating log button.
Not really, but you gotta understand. I know you're mostly joking, but some of you guys have this idea. When you're teaching, you're trying to think about future. Even if this is like the last class because you're just getting an associate's degree or something, or you're just going to take 120 or whatever. There are people in here that are going to go further in mathematics, and I'm trying to give you what you need to build on for later. So if I only showed that, you would be missing out on this, and somebody later is going to build on this, and you're like, what the shit's that?
Yeah.
Okay. So there's always a method to why I'm doing what I'm doing. I like to pretend. I like to kid myself. So this guy really does work the same way. It's just I got a little extra shit to worry about. So I still take ln of both sides, and then what can I do? Yeah, this guy can come down. When you put him down, put him in parentheses. To be honest, this kind of thing is always in parentheses. We just don't always have to show them. Like when it's on top of a big division bar. So it doesn't just magically appear. We just, oh shit, we better show them so I know that this whole thing is multiplying. And then of course, how do I go from here? Divide ln of 11. So I get 3x minus 4 equals ln 2 over ln. Now don't throw that in the calculator yet. Have you got the exact answer yet? No, you haven't solved for x yet. How do I solve for x? Add 4. So 152 divided by ln 11 plus 4, and then